Welcome to the incredible Airbus factory in Hamburg, where we've got an all-access pass to the aircraft structure and final assembly lines, component installation, and we'll be taking a look at Hamburg's specialty, the brand new A321 XLR with its innovative fuel tank and more. I've got my silly hat on, you know what that means. I'm at Airbus, this time in Hamburg at their Finkenwerder facility, which is a huge part of the worldwide Airbus network. And I'm standing above one of 4 A320 family final assembly lines right now. Hamburg at the moment is doing around 95% A321 production, and that's because those tend to be the more complex aircraft with the more complex cabins. We're talking about the A321 LRs, the XLRs, like the Etihad one that I flew recently on a delivery flight from here, where you have much more complex cabins in terms of having a business class, first class, premium economy, much more demand from the customer in terms of what goes into these aircraft. So we're here today to get a sense of the production process of these 320 family aircraft here at Hamburg. We're going to go take a look at the structural assembly first, and then we'll come back over here to do a tour of the final assembly line, and we'll finish up with a very special and exclusive look at the rear center tank of the A321 XLR. This is the famous, very complex extra fuel tank that gives the XLR its added range, that lets it fly several hours and really pushes the boundaries of what a narrow-body plane can do. So really excited to show you around and to see it for myself, and I hope you enjoy it. Let's go do it.
We are here in hangar 245, modern production hangars for the structure assembly. What we do here is we produce the section 15-19. Section 15 is where the wings will be attached to the aircraft later on, and section 19 is all the way up to the rear end. As I've just learned, you've just seen the Beluga transport one of the center wing boxes from Nantes to us, and this is actually the next step in the production cycle for the center wing box. So we will build a section 15 around the center wing box. It's more or less the geometrical point 0 for the section 15. And what we do here in hangar 245 as well is we produce our section 17. The section 17 is being composed out of 3 different shells and a floor grid. The shells are being mostly delivered from Nordenham, or solemnly from Nordenham. The floor grid we assemble here ourselves. Section 15, on the other hand, is being, as we just discussed, the center wing box being delivered from Nantes. We got several structural parts that are being delivered from Oberpfaffenhofen, from the company Nibea. Also a shell from Nordenham and several other suppliers that are delivering into our hangar here. What we see here is our so-called mezzanine floor. It's the logistics area where you can see the shells are aligned in our rail system. On the left-hand side, we see the shells for section 17. On the right-hand side, a little bit further in the background, we see the shells for section 15. If we walk over here to the right side, we actually see the first station of the section 15. What you see here is the empty station 87. It's actually being just filled with parts. So what you see right now is the keel beam. It has just been lowered down into the station on the positioning rack. The next step will be to position the center wing box, the pressure bulkhead and other components within the station. Once we have put them into the station, we will perform a laser measurement. So this hangar is all about laser measurement of our components, and what we will do, or what our computers in the background will do, is they will determine the tolerances of each individual part, and they will tell us how to position them within the station, get a so-called best fit. The best fit is using all the different tolerances of each individual CA and positions them as close as possible to each other within the tolerances that are allowed. And if we move over to the other side, we can actually see how a filled section 15 station 87 will look like. So right here, we see the same station, but a little bit further in the progress. So we already see the center wing box has been lowered down. We already see the pressure bulkhead in the back of the station, and the pressure floor grid is just being lowered down into the station. Those are 2 complete copies of each station, so both perform the same work. And once they are done, they deliver into our so-called flow line. So the section assembly in hangar 245 is being done in 2 flow lines, one for the section 15, one for the section 17. Flow line means nothing less than once we start producing, we are in a flow. Each station is tucked next to the other one. All stations have to be tucked ready when the time has come. If one station is not ready, the entire flow line cannot move. So it's always very critical to have all the forces, work forces that we need every day on point to be exactly ready when the tuck time has come on all stations. But we will have a look at this right now. So what we see here is the start of our flow line for the section 15. As I just explained, once we start into the flow line, we cannot stop. We always have to keep moving. So right below us is a prepared center wing box attached to the pressure floor grid and to the pressure bulkhead. And once the tuck line will be moving around, we will enter this part into the flow line. Afterwards, it has to move 7 different stages or stations before it leaves the flow line as a complete section 15. What is important to know is also, as I explained in the beginning, the center wing box and those major components are the geometrical fixed point for the section 15. So after we have positioned them all towards each other, the major steps that will follow is the assembly of the shells around it, the attachment of the frames. Once this has been done, we are talking about a complete primary structure, and then secondary structure will be assembled into the section 15. This mostly means the installation of brackets and other smaller parts of the aircraft. For our A320 family, the most used component is aluminium, and for some stress-resilient part, we also use titanium. What we see over to our left side right now, below us, is the beginning of the section 17. Section 17, just as a reminder, is the part of the aircraft behind the wings and all the way up to the end, which is mostly used for our cargo and PAX area. Here we get the huge shell from Nordenham. It's being transported via sea transport container. So from Nordenham, it takes the so-called Kugelbarke, which is our own ship, and it's being unloaded here in our own harbor at the site in Finkenwerder. All right, so what we see here is the section 15 again, but at a much further point within the production. So we see that the shells have been put around the section 15 center wing box, and what we see here is the so-called longitudinal joint. This one has already been finished, but alongside the upper and lower shell, and I can show you a little bit more into detail here. So the longitudinal joint is the joint between the upper shell and the side shell. And along this black line here, our so-called light flex track robot is performing all the drillings of those approximately 1,200 holes for each joint. And this was the last rivet that was just pushed in. So 1,200 holes on this side, 1,200 holes on the other side, 2 robots which have been used to perform alongside with our workforce. They perform the drilling, or they do nothing else. They just do the drilling. Our workforce does the rest, but it's a huge help, especially in terms of the ergonomic for the workforce, because it's, as you've just seen, you always have to kneel down. It's not very friendly. So we work very well alongside the robotics here that we have installed. Once this has been done, as I said, the primary construction of the section 15 has been done, and we will continue to do secondary installations along the last 2 stations. Here, for example, you see the drilling unit of the light flex track. It's been disassembled now to prepare for the next tuck. It has been mounted onto the aircraft before, but as we've just seen, the longitudinal joint has already been closed up. So here we are at the second station of the section 17 assembly. And what we can see here again is how we use laser measurement to come again to the so-called best fit. So what we do is we use this laser up here, and we have some target points along the section. We measure the floor grid in relation to the side shells and the huge super shell which we have just seen before, which has been delivered from Nordenham. After all has been measured, we are positioning it according to the best fit the computer has given us. Most of it is done automatically, and we only do a little bit of a fine adjustment manually. Just so you get an idea about what are we actually talking here. We're talking about 1/10 of a millimeter that we are positioning the parts in relation to each other. This is how accurate we are working here. What you see here now is the floor grid, which has been assembled on the mezzanine floor, which we saw at the beginning. It has been lowered down towards the section or into the section. And once it has been installed completely, the yellow construction, which we call a gripper, it's comparable to a crane, is being lifted off out of the section again. As a next step, what we do is we lower down the upper shell. So we've just seen the floor grid and the two side shells. The last shell to complete the section 17 is the upper shell. This one up here again, it has its own crane with its own gripper. Once this has been done, again, the primary assembly of the section 17 is more or less finished. And along the last two stations, we are talking about completing the longitudinal joint and installing secondary structure like brackets and so on. As a comparison, a longitudinal joint of a section 17 has more than double as much holes as a section 15, so more than 2,500 holes per longitudinal joint are being drilled and riveted at this station for each side.
What are the flags for?
The flags is a project from our hangar. It represents all nationalities that are actually working within this hangar. So every worker who was invited to bring the flag of his or her nationality, and we hung them up here as a sign of our diversity and our cultural responsibility, but also to demonstrate what a multinational project building an aircraft actually is. It's not just an obvious fact that Airbus is operating on several continents by now, but also with their core countries is spread all over Europe. But also within each production hangar, we have a very multicultural workforce which has to work together to assemble an aircraft in its whole. What we see over here is our section 1819 pre-assembly. So a little bit like the pre-assembly stations that we saw on the mezzanine, just a little bit bigger because we're talking about an actual section 18. Those are being delivered to us, so we are not building them ourselves. They run through these three stations. Secondary structure is being done, and after this we are moving into the major component assembly. Over here you see the last station before the aircraft, and the finished section 1519 is actually leaving the hangar. After this so-called belly fairing bracket station, it's so called because from below the belly fairing is being attached to the aircraft, and inside mostly bracket installation is being done. The aircraft will leave our hangar and will move towards the surface protection, where the aircraft will receive another layer of surface protection, especially from the inside, to prevent corrosion over the lifespan of the aircraft.
There are some really cool things to know about this site where Airbus is building aircraft in Hamburg, and one of the big things, of course, is that this was the home of the A380. A number of the hangars here were built for the A380 and now have been repurposed for production of mainly A320 family aircraft. And it's pretty cool to see how they've done that, made the best use of that space, where they tend to have very high structures, not necessarily as wide, because A380 obviously super tall, and we still have this VTP, vertical tailplane of the 380 here in the center of everything to commemorate it. I think for a lot of people here, workers here, but also just passengers, people who fly, the A380 remains this very iconic, much loved aircraft, and it's important to this place in an ongoing way, even though they don't make them anymore here, sadly. And for those of you who've been asking, a lot of you have been asking on Instagram, it doesn't seem like an A380neo is on the way, but I guess you can never say never, and things change over time. You never know what'll happen. But luckily we can still fly on A380s every now and then.
So here we are at the so-called major component assembly line. So we have three of those lines. Or we are producing section 15 and 17 on one flow line each, which means the flow line has to run 3 times as fast as the major component assembly line. What we see here is what we have seen through the hangar as we walked through it. The section 1819 all the way up in the back here, the section 17 right between, and at the beginning of the aircraft we see the section 15. Each section is being lowered down here via our crane. You can actually see it in the back, just delivering 3 sections towards our last MCA line. And once they have been lowered down, each is being positioned on their own tower, which we can see below here for the section 1819 and alongside for all the other sections as well. And again, what we do, we transmit all the laser measurements that we have taken during the assembly process, and we are transferring them on the computers of the MCA line in order to evaluate for each section the tolerances and to align them as perfectly as possible within their given tolerances here in the MCA line before we continue with the orbital joint. The orbital joint now, in comparison to the longitudinal joint, is describing the joint between each section. Here we see it at C64 and further below at C47, which is the positioning of the frames. And for example, one of those joint ups has approximately 3,600 holes each. So we're talking about more than 7,000 holes and rivets that have to be applied to the aircraft in order to keep the sections together. Here we do not use the light flex track robots, which we have seen in the section 15. Here we use our own KUKA robots. Each MCA line has 4 individual KUKA robots, and those robots are able to not only drill, as we've seen with the light flex track, but also to apply kit and put the rivet inside the holes. So the workforce that is working together with the KUKA robots is only performing the last bit, which is closing the rivet from the inside. So it's a little bit more advanced, so to say, than our first robot, but it performs also a different it's being used for a different purpose. So as I explained, 4 robots for each MCA line, which means they are performing their work one orbital joint after the other. Once this has been done, the major part for this station is being finished, and we are pushing the section through with our automated guided vehicles, so-called AGVs, from this station to the last station. So what we see here is the crane has just delivered each section individually into the station. As I've explained, each section is being lowered down on their own positioning tower. The crane has moved them out of the picking area towards this empty station, and the next step will be the laser measurement and afterwards the accurate alignment of each section towards the other one. So in the end, we will produce the most straight flying aircraft possible. So now, before the crane is allowed to move over the other stations where people are actually working, safety protection is being moved below the crane. This is being done obviously when the crane is loaded with sections, which actually in a worst case scenario could fall off and possibly damage not only the aircraft but also people working below it. But it's also being done if the crane is not loaded as a safety precaution.
Yeah, we're here in the new hangar, especially built for the A321 XLR, which is our long-range single-A product. You see here a hangar which has been put in operation in 2023. So an industrial system where we are doing the complete system installation. So we are installing everything what you as a passenger need for a comfortable and safe flight. Air conditioning pipes, electrical harnesses, electrical systems, freshwater, wastewater pipes, insulation, doors, floor panels. So that is our scope of work. So for that we have put in operation this hangar. Few fun facts about this hangar. So it's the first hangar here on site with a photovoltaic equipment on the roof. So we produce our own energy here, and if the weather is good enough here in Hamburg, then we can produce more energy than the hangar needs. We have also a big crane here underneath the roof, which is the longest crane our provider has ever built. It's the first hangar where we have here in our industrial system automated logistics system, which is a storage of aircraft parts, and then the blue boxes with parts are coming along the basement to the point of deliveries to bring the part exactly to the point where our team members are installing the parts.
Nice.
So you see here at this station a section of the A321 XLR, which is in the middle of the equipping process. You see the first installed systems. You see here all the harnesses for power, for data transfer and so on. You see here also in the middle an air conditioning pipe. You see air conditioning parts above the windows. The windows are installed, and the colleagues are working at the moment. The colleague who is on the floor is working on the fuel vent system, which belongs to the installation of the rear center tank. And as I have said before, we have the challenge to install all these systems to operate the rear center tank. Yeah, so the space there is limited. I show you what I mean. These pipes are part of the systems for the rear center tank. And you see here that this is the roof. So you're on top of the rear center tank. So the installation has not been completed. That is a reason why we see the tissue and so on. But we have already a few systems installed. More systems to come here in the so-called canyon. That is the area between outer shell and the rear center tank wall.
Another very cool thing about this site is that they've been building aircraft here for a really long time, way before it was Airbus. They started building seaplanes here in the 1930s. So there's an aviation history to a lot of this place, and some of the structures, some of what we've seen, actually comes from that time. In fact, in the Customer Definition Center, if you check out that video, you'll see that they've used a clock, big clock that's hanging on the wall from that time. When they used to have a lot of marine workers here. It was a shipyard, and they started building seaplanes right along the Elbe River here, and that's important to the industrial process of this place. Airbus has its own port here. In some cases, aircraft parts are shipped over to the port of Hamburg and then sent on to Tianjin, or they might go on Airbus's own ships out of this port right here down to other places along the coast in Europe before being sent out to North America, for example, to Mobile, where we've also done a video. And I'll put all the Airbus videos down in the description that I've done and that we've done at Flight Radar 24. It is a lot, and there's so much to see.
So these jigs have a weight of 80 tons. They are driving with a battery, and so with a remote control we can steer then these cycle jigs to the station where we need the section. Okay, so we are here underneath the section where we have the so-called rear center tank integrated. So that is the heart of the A321 XLR, which allows the extra long range of the product. And we are here the area of the main landing gear bay. Yeah, so in operation we would have here the wheels, yeah, from the main landing gear. And behind this area we have the so-called belly fairing area, which you see here with all the ribs, which will be completely closed afterwards, as soon as we have all the systems installed and tested. Area with the ribs, with the belly fairing panels, this is extended to give also an extra protection of the rear center tank, which is exactly behind this wall. Yeah? So we are beside now of the rear center tank. It starts at the wall of the main landing gear area, and it ends exactly here where this belly fairing area ends. And this is the fun fact here is that on an airport where you would see A321 XLR and a regular A321. The only chance to distinguish what is the XLR and what is the regular ACF, the regular A321, is the length of the belly fairing area. Yeah, so we have 2 ribs more for the XLR. The one for the A321 regular ends here underneath emergency slide box. So this tank is extra protection because of the very challenging requirements from the authorities. That is the reason why some crash cases have been calculated, and to have in that case, which should never happen, we can secure a safe evacuation of the passengers. That is the reason why we have here extra protection of the tank. Yeah, the specialty of the rear center tank is that it's fully integrated in the structure in the section of the aircraft. Yeah, so you can have also additional fuel tanks, yeah, which you put inside the aircraft, but with comparable high weight. Yeah, this tank are using the outer skin of the aircraft structure as a wall. Yeah, so that is a big benefit for weight. And in total, you have here, with more than 13,000 liters of fuel, the extra capacity to fly these extra long distances.
All right, I'm going to go up inside into the rear center tank. We can't film it, unfortunately, but at least I get to take a little look, and I'll let you know how it is when I get back, if I get back.
Okay, Gabriel.
Right.
So please watch your head. You can put a feet here on the ladder, and then you stick your head inside the RCT. So in operation, you would be surrounded by 13,000 liters of fuel. And you can see there the structure elements in green. You can also see the different systems, so the fuel pipes, the valves, and everything we need to operate the tank. And you can also see the black, what we call liner, the black elements on the bottom of the RCT to give an extra shell to the tank.
Yeah. Wow, very impressive. It all looks so reinforced, kind of very strong.
Yes.
Yeah.
Yeah. And it's like it's a huge volume.
Yeah.
I'm always impressed when I see it.
Yeah.
13,000 liters.
Yeah. And this is how the XLR flies. What is it? 8,600?
8,700 kilometers.
8,700 kilometers. The other thing to know about Hamburg, which is quite cool, is that every A320 rear fuselage section in the world comes from here. So while Airbus has this massive global network of parts coming in, aircraft sections from all over the place getting joined up in different places, if you see the rear fuselage section of an A320 family aircraft, you know it was made here in Hamburg.
So the automated logistics system brings all the materials, or 85% of the materials, to the place where the blue collar needs the parts for the installation. And we have two benefits. We don't push trolleys through the hangar with all the parts, yeah, with all the effort, with all the risk on work safety and so on. But for us, production, it's also a huge benefit in bringing the parts in the right sequence to the place where we install it. It's exactly in the sequence how we would like to have the parts and being supplied to the area where we do the installation.
There are around 18,000 people working here at the Hamburg facility. That compares to about 22,000 in Toulouse, so it's nearly as big in terms of workforce, and it's incredible how much is going on at any one time in this place. It's just mind-boggling. And Toulouse a bit more spread out, Hamburg a bit more dense. Both have very different individual characters. Really cool to see how they work together. Fun fact, if you saw the Etihad A321 LR delivery video, you may remember that there is an Airbus shuttle that goes between Toulouse and Hamburg. It's operated by Volotea, and they have one twice a day between the two to fly employees back and forth, which is also pretty cool. They have their own little special departure terminal here, which is where we departed on the Etihad flight. Another cool fact, here in the tower, they actually have a ship radar, and that's because when one of these massive loaded up cargo ships is coming down the Elbe just here, which is at the end of the runway, that means that airplanes can't fly during that time. It's not safe to do so. And another cool thing is that the Hamburg commercial airport is actually on almost the same heading and track as the airport here at Finkenwerder is. They have a tower here where controllers have to actually coordinate with the other airport in terms of lining up arriving and departing traffic depending on the runways being used, because it's such a similar kind of almost parallel path, just a bit south of the commercial airport.
So this is station 42 just here. The first thing we do, for example, on the forward section, like you can see, is we put inside the monuments. And the monuments, for example, the galleys and the toilets, which are huge. So the only way we can actually get them inside the aircraft is through the open cross-section of the fuselage. And if we would have to put them in later, which can happen in extreme circumstances, then we'd have to take them apart, disassemble them, and then carefully put them through the passenger doors. Of course, is not ideal. So what we always do is we install them here. And this is one of the quite interesting parts of the production, because it's very simple and it's a very practical thing which derives the flow and how we work here. So what you can also see as well is we're doing some pre-inspections. This forward section has come from Montoir de Bretagne. It comes in our Beluga XL and is flown across here. We take it off, it's transported across, brought inside, and of course we then take a look at it. So we do an incoming inspection. And there's some people on the aircraft right now inspecting the skin. In fact, you might think on something as huge as an aeroplane that a tiny little dent would be irrelevant, but actually it's not, because we have to document every single non-conformity. It's extremely important for safety and for our customers. And if later on, after we've painted the aircraft, when it becomes nice and shiny and you see every tiny blemish, our customers find a dent, and we haven't got it documented and we don't know exactly how deep it is, what it is, what's happened there, then we risk having to deinstall the cabin on the inside of that skin, deinstall the sidewall panels, the linings, even worst case scenario, pipes, to get to the skin, which is obviously an enormous disturbance to the production. So we're very careful and very precise about inspecting the skin.
Is this a visual inspection?
It's a visual inspection, and there are specific rules for that. And if we find something, then we measure it with test equipment, and then if it's above a certain criteria, we start doing non-destructive testing, and then rework it as required.
Right. So that's what he's doing up there?
Yeah. So you can see him right there with his torch parallel to the skin, which shows everything up. So look, he's probably going to make a triangle now, which is going to locate what he's found. From here, you probably won't be able to see it with the naked eye, but it'll still be something that we need to inspect. And okay, so now he's doing what's called mapping. The aircraft skin is split into a mesh, which is defined by the position of the substructure. So this is the preparation station for the rear section. You can see here the platforms, these yellow platforms are lining up with the internal cabin floor. This is where the galleys and monuments are being moved into the aircraft. It's quite an exciting place to work overall. Okay, so once we've finished on station 42 and 43, moving the monuments inside the fuselage, then of course we actually have to join the fuselage. And the magic happens on this station here, which is station 41. Right here you can see the front of the station, and I think when we look down the middle, you should be able to see the whole fuselage. Basically here, there's a lot of manual labor. So the first thing that happens is both of the sections are positioned, as we use a laser positioning tool for that. And then they are moved over each other, everything's checked. And then the drilling is done in 4 or 5 steps. So we drill, we clean. So we drill, we come out again, we clean. We come together again, we drill again, we clean. We drill and clean. So the holes are slowly brought up to the final size so that we avoid having any chips or bores, and everything's perfect. And now we can see from this angle that they're preparing the join. They're not joined yet, because you can see the rib 1, which is on the outside of the center wing box. Yeah, so you can see, if we just look through here on this angle. So what you've just seen here as well is the red protection around the entrance into the center wing box and workers going inside. This area needs to be cleaned. It needs to be FOD free. FOD means foreign object damage. Any kind of particle has to be removed. And also, of course, this is actually the fuel tank afterwards. So the structure is sealed, and then once we've inspected all of the bolts at the end of the wing join, which comes later, they obviously have to be perfect as well. They're also sealed. So we put a sealant on top of the bolts and the washers. And at the end, this becomes the fuel tank. This, of course, is not something we can do with robots. It's quite a long way away for this industry. or at least for this particular task. So here we go. This is station 37. So this is the next step after the aircraft has rolled on its landing gear out of station 40, and we need to start installing the flight control surfaces. So here on station 37, you can see a horizontal tailplane here, which is being prepared, and you might be able to see section 19, so the end of the aft fuselage with a little bite inside. So what we do here is we lift up the horizontal tailplane and we slide it into that gap, and then we connect it up. So the horizontal tailplane moves in its entirety. So this is quite important, and one of the most important components of the aircraft is the trim spindle. The trim spindle is a giant jack screw which is attached to the front of this, and it turns and then moves the horizontal tailplane to trim the aircraft. And this is controlled by the flight control computer, and it's happening all the time.
Yeah.
The pilots don't have to do anything for that. The aircraft takes care of it. And when the pilot gives an impulse, it's then mainly controlling the rudder, which you could see, which is obviously a control surface attached to the horizontal tailplane. So once the fuselage has been joined, then this, sometimes we call it lovingly a cigar. Then it's lifted by the big crane on the roof, brought over the top, and it's dropped back down into this station here, which we call station 40. Now, station 40 is really important, so we're actually working on 3 shift bases here. Otherwise, we're 2 shifts. And here we're joining the wings. And the wing join is actually, as an aerospace engineer, for me, one of the most miraculous, amazing processes which I've ever seen. You've got this enormous wing. You can see your wing just there, which is prepared. It's all wrapped and protected at the end from the transport, of course. And this is joined to the fuselage, and the overlap is about this much, which is incredible, right? This is a layer up of aluminium, and the total packet of aluminium that joins about that thick. It's massive. And then this is then drilled with automatic drilling machines called ADUs. So these machines weigh about 40 kilograms, and they're slotted into a template. Then they drill automatically. So it's very precise, it's heavy engineering. And then we've got titanium bolts, so we call them rivets, which are then hammered in. So we wouldn't want to be here when they're hammering in those titanium rivets. Pretty loud.
Wow. When you say 3 shifts, that means round the clock?
Round the clock. There's a lot of work on this station, so we work round the clock here to make sure we keep up with the tack time of the line. In terms of accuracy, we're on tenths of a millimeter, so very precise. Okay, so we're bringing the wings from Broughton in North Wales, UK. So of course this is quite close to my heart, and every now and again I get the odd joke. I work for production in Hamburg, and I've worked here for a long time, but of course my colleagues often give me the odd nudge, you know, that I might be protecting the UK plant too much. The wings are coming from Broughton, they're produced there, and a set of wings comes in the beluga, so we have a special jig. We have one wing on top of the other, and the whole thing slides in, which is quite impressive to see. And then it's deloaded, brought across here, and you can see them now. There's one wing there on the platform, ready, prepared. And you can see another wing there, which is, I think if I can see right, already been joined. So on station 40, we're installing the wings, as mentioned before. Here in this line, we've got the sharklets on. We install the sharklet as well. We're also installing the landing gear here, which is a milestone, a major milestone in aircraft production. After station 40, it's the first time which the aircraft rolls off on its own wheels. So it's independence. The cabin installation is starting, in fact, on 40 already. It's on station 40, it's preparation. So it's making sure that the floor structure, for example, in the join-up area is connected and is installed. And we also make sure that the final electrical equipping of the sections is connected and finished. And then on station 37, actually, we start installing the sidewall panels and the hat tracks, so the overhead bins. That's what most customers will recognize. And this station, it's still things which an aircraft customer wouldn't see because it's underneath covers.
Right.
Another important thing here, however, is electrical power on. So on station 40, it's the first time we turn the electric on.
So you get wings, landing gear, electrics on. That's like all the
right.
Key moments. Yeah.
Key moments, yeah. They're all pretty key and important. Here you can see the pylons they're used for connecting the engines. There are a lot of titanium in this structure. These are coming from Saint-Éloi in France. It's close to Toulouse. Then brought here, of course. They're pre-equipped, and we install them on this station before we move on. Afterwards, of course, carrying a huge amount of load. The engines are probably the heaviest single component on the aircraft, and these pylons are connected to the wing, 4 sets of bolts, so 2 at the front, 2 at the back, obviously have to hold for the entire aircraft life cycle, and of course they do. But you can look at the lugs, so you can see those 2 lugs there.
Yeah.
Or should I say 2 sets of lugs, because each one's 3. And this overlaps with the receiving ends on the side of the wing, and then the bolts are put through. What's also interesting, if you want to come around here, so here are the connecting lugs at the back, and these are actually turned 90 degrees. Any idea why that might be? It's actually, this is taking the thrust load. The lugs at the front are in flight direction, and these are parallel to flight direction because they're also taking the thrust load from the air. And then you can see a lot of pipes and things here. So you've got hydraulic systems coming through here. You've also got air systems coming from here. Of course, that's how the air conditioning works. We tap hot air from the engine and then bring it into what we call the mixer or the big berther, and that's mixed with cool air coming from outside to the perfect temperature and then circulated through the cabin.
This is what's known as bleed air?
This is known what exactly. This is bleed air, yeah. So this is actually quite a complex task installing this, because you've got bleed air systems going through it, you've got hydraulic going through it, you've got a fire extinguisher systems in it as well. So there's a lot going on in one small space. So this is quite cool. We also install the vertical tailplane here, and once that's done, we install what we call section 19.1, which is the tail cone. Inside the tail cone, we've got the auxiliary power unit, which is pre-assembled. So this is pre-assembled in a different hangar, and then the whole thing is lifted together and connected here. You can see the flaps here. These are the inboard flaps. So the outboard flaps are already pre-installed on the wing. The inboard flaps are installed here in the final assembly line because the inboard side, which you can see here, is actually attached to the fuselage. Right? So obviously we can't pre-install that because you can't install it until the wing's been attached to the fuselage. An extremely important part of the assembly. It completes the aircraft, and it's, again, heavy engineering. A large amount of loading going on this area through takeoff and landing. Yeah, so this is the fixing point inboard. This is the track arm, and these guys here, which you can see with the blue paint, part of the electrostatic network. We call that a bonding lead. So every metal part of the aircraft is connected that you avoid having any static discharge, which is, of course, extremely important. The aircraft is flying through the air, it might be flying through storm clouds, it might be getting charged up. So like this, everything's completely connected and you never have any sparking. So coming back to station 37. So here we install the physical flight control surfaces. We've got the flaps on, we've got the VTP and the HTP on, and then we need to connect the rest of the hydraulic connections. This is all happening here behind the scenes. All of the cables are connected, hydraulics, electrics, and then everything's finished. So it's ready to start to be tested on the next stations. And as mentioned before, obviously in the cabin, we're starting to install the overhead bins and the sidewall panels. Another important thing which we're doing here on station 37 is we're installing the flight control computers. We've got areas at the front called 80 and 90 VU, avionic base. There are racks, and then all of the different computers are installed in there. And it's not just one, it's racks and racks of them. It's different computers for different jobs. We've got computers controlling the slats and flaps, for example. We've got the air data inertial reference system, the list goes on. So we've got station 35 here. Now we've installed the physical flight control services. Everything needs to be connected up. We've just installed, for example, the VTP and HTP, and then the actuators need to be connected, hydraulics, electrics, everything which runs through. It's all done here. Then once that's finished, we start looking at the fuel. The system is now complete. So all of the areas have been checked, they've been sealed, the fuel pumps and pipes have been installed. Now we do what's called the PLT, pipe leak test, which is done on this station. So pipe leak test is done, and then we do first hydraulic tests and make sure that the hydraulic system is working right. We also do what we call Delta P, which is cabin pressurization. We do that right here. What we do is we pressurize the cabin to the same pressure differential which you'd have in cruise flight, or a very similar pressure differential. Pressurize the cabin and make sure that everything's sealed. In addition, depending on the cabin complexity, we also either start or complete the cabin installation here. Cabins are getting more and more complex. Most of our products are here now are the A321 cabin flex, 3-class cabins with business class seats, economy, premium economy, and then different in-flight entertainment systems depending on what the customer's ordered. So if we have a complex aircraft here, then we'll just start the cabin completion, and then the rest will be planned in another area. And otherwise, if it's a simple one, then we do it here. I think, seeing the cabin when it's finally complete is always amazing. That's when you really notice it's come together, and you can see what we're then really selling to the end customer. The paint job as well, the final livery. It's always quite a glorious moment when the final livery is done and you can see the aircraft outside in the flight test area in the sun in all its glory. I actually used to be customer manager, so when I was doing that job before I was in this final assembly line, we would shake hands with the customer at the end of the delivery process and we'd watch them fly away. And that was usually quite emotional. Well, the next step after this hangar, it does go on one more station on the other side of the road where the cabin completion is continued. And then after, and of course the complete tank leak test. So here we only do the pipe leak test for fuel, then we have tank leak test on the next station. Then it goes outside and we go on the fuel gauging position. So that's when the whole fuel system is completely filled and checked. Then it gets engines installed, and before that, or before or after that, it goes into the paint shop. This massive hangar door opens all the way to the side, and then the aircraft can move out of the hangar onto our streets, and obviously then into another hangar. That's one of the nice things about working here. You have very special types of traffic jams. Obviously, aircraft always have right of way, and if an aircraft is outside between the hangars, you wait, and we're usually happy to wait because it's nice to look at it. This guy here, called the Easy Mover, which looks a lot like a Hoover, is actually used for moving an aircraft. So it's using these rollers, and it takes advantage of the moment arm you have through the size of the nose landing gear wheel. It rolls the nose landing gear wheel and therefore moves the entire aircraft, which is quite amusing to see because you've got a worker using what looks like a Hoover tacking the aircraft.
Thanks so much for coming along today as we took this very special tour around the Airbus Hamburg facilities. So much going on here in what feels like a very small space, just an incredible amount of industrial activity, innovation, just great people as well, every step of the way, meeting some of the great people who are doing this, who are putting together these airplanes, making sure that they're as well made and safe as possible. And just, it's always so impressive to see the kind of logistical puzzle that comes together in such an efficient and streamlined way at Airbus facilities around the world. I've been to a lot now, and every time there's new things to discover, and so cool with how they're managing to take that A320 family aircraft, a design from the 1980s, and continue to stretch and innovate it, not just stretching it in terms of length, but in terms of its capabilities and what it can do for airlines. So very cool to see all of that. And of course, to see all of the Beluga action. That's a separate video, which we'll link to all over here. And I hope you enjoyed. Let me know if you have any questions, anything that you still want to know about Airbus and what they do in Hamburg especially, and we'll do our best to answer them in the comments. For now, thanks for coming along in Hamburg for Flight Radar 24. I'm Gabriel Lee.